In this lesson, I want to start working with the flip simulation. So what we want to do, I take my dynamic scene and I rename it as flip sim version 1. Why I want to use this scene as a start point? Because we have dynamic, we have the cache from our dynamic. I want to remove all those files I don't need anymore. I just want to use the cache from the RBD dynamic as we did over here. So we're gonna grab my, oh come on, something wrong with my mouse, the ship render, and use this geometry for collisions. So what task we need to make? This thing we will remove. I'm gonna keep ship animation and I will remove this. Need constraints. So let's remove it. Oh, sorry. Let's remove this and this. And with the dynamical, what I want to leave just a ship render. So I'm gonna remove all those guys here. I'm gonna delete. All right, and let's rename it. It's gonna be my ship Vdb, and this is gonna be a ship animation like it was. So with the ship render, let's take and let's go and select like frame 24 and go to auto update. I want to see my ship. It takes some time because there's a lot of geometry. So what we need to create for a flip simulation. In our case, I want to use the flip simulation for creating some splashes around the ship, around the body, because with the explosion, especially with the second explosion in beginning of frame somewhere 46, we will create like a wave around the ship. Again, I saw this in reference in the Midway movie. Because this ship is not moving in static, so I don't need to create some kind of simulation around the ship. But again, sometimes the geometry wave which go inside of the ship is not looking very good, because when the ship is, even if it's static, if it's not going through the seas, through the water, the waves is bouncing with the body of the ship and it's creating some kind of a foam a little bit. So in some cases, if you want to have a nice realism, if you want to have a real interaction between the water and the geometry, just for these purposes, you need to create a flip simulation. It shouldn't be like super quality. It shouldn't have like 100 million particles, but just for a little bit of interaction, you can do this. In our case, I want to create the water pool around the ship, and in this case, not from the both sides, because we have the camera just from this view. So for the right side of the ship, well, right side from my view of the ship, I want to create particles. I want to create the flip simulation and add some forces which will push those particles near the ship to create a simulation like interaction, because the ship is like, with an explosion, it's move up with high speed, and you should have some interaction between the water and the ship. So to do this, we need to make a few things. The first thing, we need to create the collision geometry, because the water should collide with our ship. But in this case, I'm interested just with geometry near the water surface. I'm not interested with those elements. Also, if you want to, if your scene, you can try to create the scene bigger than 100 frames. And in this case, we will have some elements which fall into the water. And this is another example how we can use the flip simulation for interaction with water. In our case, on frame 100, we don't have too many elements which fall into the water, maybe around this area. Also, we can create some kind of the explosion wave on the surface. So there is many cases we can use the flip simulation. All right, so in the beginning, what I want to do, I want to remove all my small elements, because I didn't want to convert them into the VDBs. Some of those is very small, and it won't be useful for creating the VDBs, and they won't have any influence on simulation, on our flip simulation. So let's add a blast node and go to properties, and I want to select my group. So again, if my con name, how I forget my attributes. Content should be a static, as I remember. Should be a static. Oh, come on. It's loading a lot of geometry, so that's why we need to remove some elements which we really don't need to use. And also I need to clip my geometry and leave just those parts near the water surface. So with the blast node, our con type should be static. All right, static, and is in primitives. So if I again enable my blast node, we should see all our geometry without the small elements. All right, there's no small elements. Now with some clipping. So I will do some extra clipping in the flip simulation. I will change, I will leave geometry just near the closer to water surface. So there will be like two clipping levels. The first clip, I want to cut all geometry on the deck. So all elements which will be higher than the deck, I want to remove. So the first clipping is a remove geometry under the water. So with an origin, I set -1, and with the direction, we're going to keep 1. So I don't want to use a 0 because we have a wave, and sometimes wave will push our points upper than 0, and then they can, move them down below 0. So that's why I want to remove our geometry in 1 meter above the water surface. And the next clip, you can see there's many things we need to do, so sometimes it's really heavy for calculation. The next clip, I want to remove all geometry, so not above the water, below the water, all geometry above the deck somewhere, so maybe like 10 or 8 meters, let's say 8, and let's say direction -1. So when I type 8, it means that I'm gonna remove all geometry. You can see direction 1, which is have the vector which is rising up, and this means that I will keep all geometry in y direction. The point position will be bigger than 8, but I want to have the negative value, so -1. It will mean that I'm gonna remove all geometry which will have a position more than 8. We can say like 7 or 6, but just in case my splash will be bigger, we can leave it. Anyway, there's can be many things in flip simulation, so in any case let's reduce it maybe to 7, because I don't need to have those guns and all those small elements, really. But otherwise we can even remove more geometry later. So what I want to do, I want to take the geometry and convert this into the volume, because if you create a flip simulation, all our collision geometry should be a volumetric object, not geometry. Okay, so let's keep it. You can see that we begin to remove some elements over here. All right, so let's set 8. Anyway, let's set 8. And if you want to convert this into the volume, we need to use some kind of, Vdb from Polygons. It's the best way to do this. And even with some optimization, we have a lot of time for calculation. So Vdb from Polygons. And what we need to have, I press escape, because sometimes with the big objects, we don't need to use such a high quality. But in this case, let's update it again. I want to look at my geometry. So let's go to manual update. I want to look at my geometry just when I want to do this. So I guess the voxel size 0.1 can be good in this situation, because I want to have a high quality geometry. And in this case, what we have a very thin areas like the deck and some elements of the ship. You can see we have some kind of, there is no holes because we have a pretty thin geometry here, but we have holes on the deck. Again, we don't need to use a deck because I get that there is no elements on the water which will, move in such big distance from the water and go into the deck. But anyway, I'm going to use like 0.75 or 0.075 to create even smaller voxels. Okay, so again, I don't care about this deck. I'm more interested in this area. So if you want to have more details on a deck, you can make this much more smaller. So 10 million voxels, that's fine. All right, so the next thing is I want to create also the velocity field, because we have, especially after the second explosion, we have many elements moving from this area, moving closer to the water surface. So I want to transfer this velocity into the flip simulation, because it's very important to understand that when we create the field, in real life, if we have moving objects, well, it's by default we understand that there is some velocity because this object is moving. But in the 3D, the fact of moving and the actual moving is a big difference. So if you have like fragments moved from the ship, they exist from frame to frame. So let's draw this. Okay, so in the frame, let's say 25, when we have an explosion, this fragment somewhere on the ship. On frame 26, this fragment will move in the next position, in the different position, okay? But for the program, there is no movement, in fact. So for the program, we have, where's my mouse? Hey, oh, here we go. I can see cursor on white. For the program, there is no movement. We have just some volumes in this frame and some volume in this frame. So if this element will go inside of the water, let's say it's the water tank. So what flip simulation will do, if you don't have a velocity field, it will just cut some elements, cut some flip voxels or liquid particles from this volume, and that's it. So it won't create some kind of tunnel inside of the liquid, because it doesn't know. It just appears on this frame 26, and that's it. It doesn't move for Houdini, for the flip simulation. So it's very important to have a velocity field to make program understand that this thing is moving, because we have a velocity vector. So if velocity vector like here, so this means that this element will move through the water, will move through the volume, and will create some kind of a tunnel, will create some kind of interaction. All right, so in this case, I want to do the same. I want to create the velocity field from my ship, because there is some moving objects. Right, how we can do this? We can set plus here, surface attributes, and we can select which attribute I want to transfer. You can see all our points attributes. Well, different attributes, primitives, vertex, and points attributes, which I want to transfer into the volumetrics, into the volume. So in this case, I want to put my velocity, which is point V, and let's create a surface val. So surface val field will create a velocity field from the geometry and select a vector type like displacement, velocity, acceleration. So now in this case, if you look at the info, let's update it because it should be updated. We should have two different fields. The first one is the surface field, which is a float field, will show us the distance. So as you know how it works as df field, I guess if you want to know it, you can go on internet, and there is a lot of videos, free videos, for understanding how it works as df fields. And the surface field will show us the distance between the surface and inside and outside elements. Okay, so the -1 show us the inside areas, inside voxels, the positive values outside voxels. So basically, we store the information. We store the distance, so it's not like a float field, like I don't know, like a density. The density field shows us the density inside of each voxel, how many density there. But the surface field shows us the distance to the surface, which is very important, and the value show us in each voxel of the grid, it will show the distance to the closest surface. Okay, so it will be negative, it can be positive, negative distances for the voxels inside of geometry elements, and positive values for voxels outside of the geometry. And the surface val is of a vector 3s, so it's a vector field which will add velocity elements. Well, the first thing is, well, on frame 24 there is no velocities, but you can see it's kind of density is semi-transparent areas, and this is our velocity fields. Houdini can't understand how to visualize velocities in this case, so what I need to do, I want to set the visibility node and remove the visibility from the surface velocity. So I don't want to look at this field anymore, and with an updating we can see just the surface. Okay, so it doesn't remove the velocity field, it's here, but it's not visible anymore. All right, and the next thing I want to do, again, the velocity field, especially if you want to store this information, that's what we will do very soon, I don't want to have such a high quality velocity. Okay, because there is a lot of info, there is a lot of data. So to make it more, less consuming the space, because if you will use this cache later on for strip simulation, if you're gonna have like gigabytes per each frame, this will be very slow to just read this information. So it's not just about the space on your hard drive. You can have like 10 terabytes drive for this project, but it also important how quickly you will make your simulation, how quickly you will get this information from the disk. So in this case, what I want to do, I want to make a Vdb resample, so I can take my surface velocity field and make it a little bit less, decrease the quality for this. So you can use using voxel scale only and make the voxel scale like 2. It means that now we have a field, let's update it. We're gonna have the velocity field a little bit less quality, but we can still get information from this. We don't need to use, like very high res info from the velocity. We need to have just understanding where this velocity will exist, and we can apply this velocity for our simulation. All right. So now let's store this info, and I want to use the file cache to store this information. So let's create a flip folder to store this info inside of this flip, and or not. Let's let I go to my X drive because I don't have too many free space on my project drive. So let's go to X, and I have a Houdini folder there, and the ship explosion. Somewhere inside of this ship explosion folder, I will store this, and let's call this guy like a flip and geo, flip geo, then $OS, $F, BGOST. That's all the thing I want to store now. So I will save from frame, I will save from frame 24. And I'm gonna store this information because you can see how many times I spent for creating this geometry per each frame, and if I don't want to use the caching, it will decrease or increase the simulation time much more. Ship cache, let's call this. And now I'm gonna save this guy, and we will continue. And we store this info. So that's what we have. Let's go to frame 24 to look at this. And what I want to do next, and that's going to be my, it's not a source, it's like a data for a sim. Now let's create geometry. I want to add, like we did for all volumetric simulation, we need to have a source, we need to have a simulation, a node, and the import or caching. So let's create the flip source and create the DOP network for creating a flip sim, and create another geometry for creating flip cache or flip import. You can call this as you want. So let's do, okay, that's a noise. And we're back. As always, I store this as version 02. So let's change our interface. Now, what we need to do here, let's go to flip source and again select this. I want to just disable the visual representation of this guy. So copy ship cache and go to flip source, object merge. And this is the first source we're going to have is our ship, our Vdb ship. So what we need to do else? Before, let's rename it, it's Vdb. Before we use the ship, we need to create some kind of pool for the ship, the pool for the water particles. To do this, I will create the box. I already know the dimensions from this box. So let's say it's 24 as I remember. And a minus. And I want to copy this guy, copy parameter and paste relative for reference. So I want to divide by 2 and set like -2, I guess. So I want to remove the 0. I want to take my height of this box and delete it by 2, so it will, oh come on, I need to rotate it. So this is the box. Let's template it box and look at the ship Vdb. So you can see that I create the box for the right side of the ship from this view. I don't care about the water in this side because I won't see it from my camera. All right, so this is my region when I want to create a simulation, liquid simulation. It's pretty important. And for the tutorial purposes, I created very, very close to the ship. If you want to create some kind of interaction, maybe with some explosion, I don't know, the shock wave or elements falling into the water, you definitely need to create a bigger box. So this box is set in null object, and that's gonna be my, let's call this active zone, AZ. And we're going to use this active zone for creating the container around our flip simulation. But before we're going to hit, we need to create some kind of a pool. So you can see that our container is going down about like 2 meters down below 0. So 2 meters, that's I think will be enough for like the height or the thickness of our water surface. All right, so what I want to do, I want to clip this geometry. So let's connect it here. I want to cut geometry bigger, higher than 0. So creating some kind of pool. All right. I can use the exploded, oh sorry, not exploded, the poly extrude. Can use the intersection. So the poly extrude will extrude geometry from the side. So I can use the distance like 0.5 to create a geometry around this pool and output back. So you can see now we create the pool for the water. All right. And for the next thing, I want to add the polyfill to take my cut objects, and using a single polygon, I create this geometry. So this geometry will be the source for our particles, and this geometry will be like a geometry for collision. It will keep those particles at this place. They won't fall down because we need somehow to keep particles. And this is our pool geometry, and this is our source for particles. So now let's add the flip source this node allows us to create the source. And as you know, maybe not, that it's created two different types of information. The first thing is the volumetric. So you can see that we create a surface VDB with voxel size 0.1 by default. So let's say polish 0.2. You can, reduce it later. And also it created particles. If you press W, you can see that inside of this field we have a particles. And the particles amount depending on the particle separation parameter, which can, set the distance between, the closer distance between the particles. Again, let's make it 0.2. Also, to decrease the particles amount, we can decrease this parameter later for our final sim. For the test proportions, I guess 0.2 can be pretty good. So how many particles do we have? With the surface VDB, we have over 2 million voxels, and with particles, we have 1.5 million points, which is good for our test simulation. I don't need to change it here, nothing more. So let's add a null object, and this will be our source out. This is the source for the liquid, and this is our poly extrude. Will be, so this is our geometry. I'm sorry. This is our, I don't know, I can call it pool geo. And I need to, if I want to make an interaction between the particles and this geometry, we need to convert this pool geometry to the volume. So surface, maybe the same 0.2. Okay, and set another null object. That's going to be my, let's call it water bound. All right, so now we can see that we have some sources. Let's start to do a sim. Go to flip simulation. Now we need to create a flip solver. So it's a standard flip object, standard nodes to create a flip simulation. Let's add the gravity in the beginning because we definitely should have a gravity force. Also, we need to have a static object, static solver, and merge those elements to our sim. It's connected here. Okay, so with the flip object, I want to use, we can use the narrow band. We can use this, let's call this narrow band. Let's use the guy. The particle separation is 0.2 as we know, and let's connect this setting. So copy parameter, let's back to flip source, and inside of our flip source here, let me colorize this. Oh, sorry, this voxel size. Here we go, paste relative reference. Because I want to have the same particle separation for the flip object and for my source. And now I need to have a source. With the static object, it's a little bit easy because we can select, not you, sorry. We can select this pool geo to set a geometry. So the soap path is for our pool geo. With the collisions, I want to look at the collision guide. Let's go somewhere to frame 24. So you can see that we have a geometry. But if I hide display geometry and enable collision guide, we can see that there is nothing here because I want to look at the volume sample. And I want to add my volumetric into the proxy volume. So let's select this water bound, copy, and paste it here on the proxy volume. And now we should have something inside of our volume. Here we go, our proxies, our VDB. So I don't need to display geometry, so I can leave this and disable. I know that it's there, so I don't care about visualization. So now there is two ways we can create particles for our liquid. We can have a pool over here using the soap path, or we can use the volume source as we did for our pyro simulation, connect to the last input, which is sourcing, and let's grab our particles here. So select the source out, copy, go to flip sim and paste it here. Also with an initialize, I want to use the source flip, and it will automatically update our sim. You can see that now we have our particles, and it automatically grab our surface, and also will grab the particles and kill inside of the DAP. Before going ahead, I go to flip object. I want to change my particle visualization from the sprites to particles. I don't know why this is by default sprites, because in all tutorials and trainings I see that all switch to particles because it's visually much better to look how this works. All right, so now we need to go inside of the flip solver, and the first thing I want to change is go to our volume motion and change our volume, how's it called, volume limits, right? So we can see that by default this volume limit is 50 by 50 by 50, and you can see this box around, but I want to take my dimensions from the source. So here how this AZ, which is active zone, I can copy and paste here. So to have a, I can't create this box, with the same rotation, because we don't have rotation. We don't have rotation here. We can create the box just, in the proper position. So what I want to do, I want to create a bounding box around this element, and I type bounding box. Now I put my element here, press comma, and then when I press space, you can see it's like a little help, what type of bounding box I want to use in this string. So we have by default, we have the xmin, ymin, so we can set the maximum value or minimum value. But I'm more interested in the size per each axis. So in this case, in X box size, I want to use the DX size. So the DX size, I'm gonna select it all, copy, tab to the next, and change to Y size. Tab to the next, Control V and Z size. If we press here the box size, you can see we have some dimensions, and now we can see that our container is around our emitter will automatically build it. Also, I want to set a center for the box because we have many empty area here under the water, which I don't want to use. So in this case, I'm going to use its centroid command, and mainly I'm going to use the same operation. I'm gonna copy this guy, and then again, sorry, I said I want to copy just the path. Control C, add a path here, comma, and now we can see that we can set the dimensions. So dx, dy, or dz. Dx, Control A, Control C, tab, Control V, Y, tab, Control V, Z. So now we have a proper and the size and the center for our flip simulation. And that's cool. You can see our particles. We have a flip sim. We have a proper source. And what we need to do next is creating the collision for our particles. So there is a few options how we can add the colliding objects in our sim. The first option is using the static object like we did with our geometry over there. But if we're interested into transferring the velocity field and all other elements from the source, I prefer to use the volume source. So in this case, I'm gonna rename it like a water source, because it's the source for our particles, water particles. And I'm gonna use another volume source to get the ship collision. Well, let's name it ship surface. All right. And what I want to do, I want to connect it to the third input, which is volume velocity. I'm more interested exactly in the velocity. Not too many care about the volume themselves, but I want to use the velocity mainly. So let's go again to our flip source, select. So, okay, now we need to create the volume. We need to create the source from our ship Vdb. So we have, as you know, we have two fields here. We have a surface and surface velocity. From one side, it can be enough for our simulation. But what I want to do, again, I want to cut unuseful elements. I'm not interested in the velocities or some distance fields over here. I'm more interested in somewhere on my geometry closer to water surface. So what I want to do, I want to split this geometry and set the surface velocity here. And well, let's say just the surface. So now you can see that from the first output, we're going to have just the surface. From another output, I'm going to have the surface velocity. So what I want to do, I want to limit my geometry. So let's imagine that we have some moving geometry, or we have some multiple objects, and we want to save information just inside of my simulation area. So in my active zone. So I'm not interested in geometry or volumes outside of this active zone. So what we can do is creating the bound. So it's the same operation like we did with bbox function. If you say bound, you can see that we have, press H, we have the box around this active zone if I template it. So it's going to be the same, like it will have the same proportions like our flip tank inside of the flip simulation. It's not a flip tank, sorry, like our active area, this box size like we did here. And I'm going to use this bound to cut all geometry outside of this bound. So how we can do this? We need to convert this geometry into the volume. If we want to cut from the volume, we can use the Vdb from Polygons. Come on. Let's set the voxel size like 2. I don't care about the quality of this box. Let's say 1 maybe. And I want to use the Vdb Combine. It's a very powerful tool, allow us to make many different operations with volumes. We can combine them, add, subtract, copy, and many different operations. So in this case, I want to use the SDF intersection, because I want to find the intersection between two volumes. It takes some time for calculation. I want to stop it for the moment because I want to change the values, go to manual mode. I want a surface here and surface there. So we have a group A and group B. So the group A is the first input and group B is the second input. All right, and B to match A. So we take the resampling, we take a sampling size from the first input, which is important. I don't care about the quality or the division size in the next, as the second input. All right, so now what we're gonna have, you can see that we cut some elements. Well, what's wrong with this? Let's update it to look at the result. I switched to auto update because it doesn't want to update this information. I don't know why. So you can see that our geometry doesn't have too many changes because our bound is pretty big. If you look at this, is covering all ship. So if you want to, you can disable the bound and use this active zone for cutting elements from the ship, like here. Anyway, you can do this or this. And another thing I want to do is I want to clip my velocities. So I'm going to connect this guy and go in here and set the velocity surface val, clipping using this element. Okay, now merge it. Let's see a difference. If you look on the original ship Vdb, which we store, we have 12 million for the surface and 1.5 million for the surface velocity. Now we have the 7 million for surface and the same for the surface velocity, because on the frame 25 there's not too many velocity in fact. All right, so the next thing is, let's set a null object, and we're going to use this information to paste for the flip sim. So collision source. I'm gonna store this file because I want to, keep this info. Sometimes it crashes, so I don't want to do this. I want to reload within again. Okay, the next thing I want to do, I can go to the flip sim and I want to change the start frame. For now, let's say 23. So let's go inside here and for the faster calculation, I want to start from frame 23. Okay, so let's go to ship surface and paste, oops, I think I copy it, but I'm not. Control C, inside here, Control V, collision source. And let's go and select the source flip or, collisions, right. So we're gonna change the collision and V, so let's make it wider. So as a source volume, we're gonna take our surface. And for the source volume, we're gonna take the surface well field. To check is there any information from this volume source, we can go to our visualization, hide particles, and look at the collisions. So with the collisions, we're going to have our water pool, and also we're going to have our ship, which is here. For visually, it's a little bit worse. We cannot just small lines, but anyway, it should be there. Also, the collision velocity, we have some information. It's using the slice, so it doesn't represent the old geometry and old volume, but we can see that it exists. And let's hide our limits. I don't want to look at that. So we have a collision velocity, we have a collision, that's nice, and that's how we can work for now. So again, what we have at this moment, we have a geometry and a source for creating the water pool, and we have a collision object, which is the part of our ship, the part closer to the water surface. All right, we have a gravity. Let's set up some flip solvers and set up some parameters inside of the flip solver. So what we need to change here. So in the first tab, we have the sub steps, which I will use by default. Let's set it to 1. I'm going to change it later. For the quicker simulation, we can set just 1 sub-step. So because we have 2 different data types, we have particles and the volumes, we have a separate motions. We have a particle motion and the volume motion setup. For the particle motion, what we can do is, let's use the ID attributes. Maybe we're going to use this attribute for creating the white water source. Also, we can create a droplets. So what is the droplets? Our particles mainly exist inside of the volume. So we create, the particles are mainly used for creating nice shape. If we will use just the volumetric, our shape will be like created from the Lego bricks. It won't be too smooth and it won't have any, small details. So to avoid such thing, we create, Houdini create a flip simulation. So it's like a combination, combining. If we, use just particles, calculating velocity for each particle individually will gonna take a lot of time. Let's say if we have 100 million particles, But if we take particles and particle simulation and put this particle simulation inside of the volume, so our volume we use mainly for creating the velocity. We push our particles through the volume. And this flip method is way faster and more accurate rather than just volumetric or just particle simulation. Because in the beginning, working with liquid will be very hard because we don't have a volume, so we have just particle simulation. And it's good if you want to create some kind of, water falling into the glass. And if you want to glass with some water is nice, we can use like 10 million particles and that's fine. But if you create a large scale simulation with a lot of water moving through the city, or we want to create a nice water surface, the ocean surface, some kind of this, we need to create 100 million particles, even more. And we can control each particle separately. Well, we can do this, but it's going to take a lot of time. So in this case, this flip model will speed up the process because we can create less accurate velocity field but more accurate particle positions and separate them and then use this information for creating a nice water mesh. So the droplets, why I'm talking about this, the droplets will calculate if some of those particles will move out of the surface, they will be transferred. They can be transferred as a separate particles. They can exist outside of the volumetric field. So what we can do with those particles? we can blend them with fluid and just mark them as the droplets. Or what we can do, we can kill on the detection. All right, so this means that if we have some droplets, we just remove particles. So we have the particle density minimum and maximum. It means that how many particles we have in one group. So let's increase this particle density a little bit more as a minimum. Okay, so it means that if there will be some particles flying away from the volume, we will just kill those particles. We're not interested in such small splashes because we're going to use the secondary element like white water to create a splash and foam. Also, if you want to create white water, we can select and add a vorticity attribute. This parameter allows us to store the vorticity for each particle, and we're going to use this attribute for generating the foam. So it won't have any influence on the simulation, so simulation will be the same. It doesn't mean that we add vorticity to the sim, because sometimes people say that, okay, I want to have more like nice live water, so I add vorticity to the simulation. We're adding just attribute, so there's no influence on the sim. We're adding just attribute, and we store this attribute to each particle as an attribute. So we're going to keep the preservation rate the same, and the collision detection, let's move out of side collision. So the volume motion, we have some changes over here. Yeah, with narrow band we can enable the particle narrow band and leave it by default. So with the volume motion, what we have here, so mainly all those settings is meaning the velocity control. So what we can change is out of our velocity field. So we have the splashy kernel. There's two different velocity transfer, swirly kernel and the splashy kernel. So the splashy, that's what we're going to use. And also we have the velocity smoothing. Basically it's like a blur applied to our velocity field. So I don't want to have a very big blur. In fact, 0.1 is good for nice smooth water, but in this case I want to have more like splashy results, so I decrease the volume smoothing a little bit. I don't want to blur this too much, and I'm gonna leave all those elements like they here. So I don't care about the surface tension in this scale. I need to change the different densities because we can apply different density attribute for our particles. I don't want to have viscosity, and with the collisions, I guess that I don't want to stick in collision. Again, if you have the liquid going through some objects, you want to create some kind of web map, you want to stick some particles on the geometry, especially if you have a high viscosity, that we can change here. But all what I'm interested in just a standard liquid with a little bit of less velocity smoothing. Alright, so if we start our sim, I hope that I'm going to see some interactions between our ship. I hope I will see the line inside of this simulation. It will mean that our ship's surface is having influence on our water and all other stuff. So beginner frame 25 somewhere, we should have it. Okay, I want to make a little preview and we're going to see the result.